Okay, so let me show you how to do this in SPSS. You go to the Analyze menu, and then you want to compare the means. Whoops, and you want to choose an independent samples t-test. And you're going to get a dialog box that pops up. First of all, you've got to choose your test variable. This is your dependent variable. And in this case, we want to know what the effect of teacher experience is on their evaluation score. So I clicked on that, and I added it over as my dependent variable. Now I have to choose my grouping variable. Remember, I've got the teachers grouped into those who have 5 years or less experience and those who have more than 5 years experience. And that is this grouping variable. So I'm going to put it in as my grouping variable. Notice that it pops up with 2 little question marks. That's because I need to tell SPSS what my groups are. Group 1 is my teachers with the least experience, and I designated those with a 0. That's their code. Group 2 is my teachers with 5 years or more experience, and their code is 1. Don't worry about a cut point. That's if you want to say take this group of teachers above this mark and this group below. In this case, we've already defined our groups. So I'm going to click continue. And now I have years of experience as my grouping variable, and I've told SPSS what the different groups are. Now, I'm going to click on options because I'm going to set my alpha at 5%. SPSS has a default confidence interval percentage of 95%, which is my alpha at 0.05, which is great. So I'm going to go ahead and leave the default. If I wanted to change it to 10%, then of course I would drop it to 90% in this box. This part of the dialog box about missing values is in case I have a teacher who perhaps I don't have their years of experience, but I have an evaluation score and they're part of my data set. I can tell SPS how to handle cases that are missing different things. So don't worry about that, how we exclude cases and different things like that, because remember, this is a cooked up data set that I made, so you're not missing anything. So I click continue. Now I've set my probability, I have my dependent variable, and I have my grouping variable in here. So now I'm ready to tell SPSS to do all of the work for me. And I get a printout that looks like this. Okay, let's look at what we've got here. Here it is, so that we've got the right one. Let's look first of all at the group statistics area. I've got my dependent variable listed here. Then I've got a group where the teachers have up to 5 years of experience, 5 years or less. And there are 13 people in that group. Their mean score on the evaluation is 15.85. and their standard deviation is 1.676. In my other group, which is the teachers with more than 5 years of experience, there are 12 of them. Their mean is 19.25, and their standard deviation is 1.712. So that's my information about those two groups. Now I want you to look at the independent samples test box down below that. You'll remember that with the independent t-test, we have to worry that the variances in both groups are roughly the same, that they're homogeneous. So we needed to do a test for the homogeneity of variance. SPSS automatically does that for us, and it's called Levine's test for the equality of variance. What you need to do is remember that your your null hypothesis for the test of homogeneity of variance is that the variances are the same, and you're looking at how large that ratio is when you divide one variance by the other variance. Levine's test for equality of variance shows us that. This F-score here is your ratio right there, and it's 0.016. That is darn close to 1, which is a good thing. It means that the variances are the same in both my group 1 and my group 2. Look at the significance. It's way, way over a level of 0.05. That is cause for celebration, because it means that my null hypothesis that the variance is the same, I'm going to keep it. I don't have an F statistic that's high enough or significance that's low enough to reject it, and that is a good thing. I'm a happy camper. My equal variances are assumed. The nice thing is that SPSS automatically runs the test both ways. It runs it with the equal variances being assumed and the equal variances not assumed. But you have to know which of these two lines to use when you report out. In this case, my ratio is very, very low. My significance is 0.901, so I'm going to keep my null hypothesis that the variances are the same, and I'm going to use this top row going across here for reporting purposes. I don't have to use this one because I've got equal variances assumed. So let's look and see what we found out. I've got a t-score here. Here's my test statistic right here. It's negative 5.022. What that means is that group 1, their mean is 5.022 standard deviations below the assumed mean, the mean of the other group. So my degrees of freedom are listed here. I had 25 people in my sample, so my degrees of freedom is 23. Let's look at the significance. Great. This means that my test statistic, was above that critical area for rejection. And it means that I can reject the null hypothesis of the two groups their means being the same, and it's less than 0.05 for my probability cutoff. SPSS also gives me the mean difference between the groups. In other words, the difference between the mean for group 1, 15.85, and the mean for group 2, 19.25, is 3.404. Here's my standard error of the difference. Remember the 3 steps you had to go through to figure that out so that you could run your test statistic? And it also gives you a confidence interval. Now notice with the confidence interval that the confidence interval in this case goes from negative 4.806 to an upper of negative 2.002. In other words, we're pretty certain that 95% of those teachers' eval scores are between negative 4.81 standard deviations below and a negative 2.002 standard deviations below. So 95% of those teacher means for their eval scores fall within these standard deviations. What is really wonderful about this is that 0 is not in this confidence interval. If 0 was in this confidence interval, then my significance would be above 0.05 and my test statistic would not be statistically significant. It wouldn't be in the area of rejection. So that's how these pieces work together.